we come back from Thanksgiving break, we'll jump into that next module. So last year, actually a number of years ago, you would have learned, and then you definitely did it last year, slope-intercept form. It's the most common form for writing the equation of a line, the whole y equals mx plus b idea, something you've heard as freshmen, as eighth graders. That's something that you would have been introduced to. As long as it's in this form, so notice how the y is isolated. Whatever number is in front of the x, that's always going to be your slope. And whatever number is tacked on at the end, that's always going to be your y-intercept. So for us to use slope-intercept form, there's two pieces of information that you must know. You better know the slope, and you better know the y-intercept. And if we do, then we can go right to that. We can go right to y equals mx plus b form. Last year, though, Math 1, you were also introduced to something called point-slope form. Depending on what teacher you had, some teachers teach it this way. All right, the little y minus the y coordinate of your point, and then your slope x minus the x coordinate of your point. And then some teachers like teaching it this way. They're both the same. All that's really happened is we took this little minus y, we added it over. So it just depends on which teacher you saw. I'm going to go with this guy. All right, we're going to go with that point slope form, but it's really the same version. What we need to do that, we still need our slope. So if you look at both of them require us to know our slope. In point slope form, we can use any point now. It doesn't have to specifically be the y-intercept. Any point that's on the line, we can use to put this in the point slope form. And when we do, it's going to look like that. Okay. So all I want you to do real quick, just to kind of refamiliarize ourselves with those ideas, go through 1 through 4 and identify which form this is in. So you're either writing slope-intercept form in 1 through 4, or you're going to write point slope form based upon just the way it looks. All right, so if you look at 1, is it slope-intercept form or point slope form? Same with 2, 3, and 4. Make sure we have that idea down pat. All right, Julia, number 1. Which one is that in? Good. This is classic y equals mx plus ab here. So this is slope-intercept form. All right, Ben, number 2, what do you got? Good. Y, and then we have an mx plus rb. So that's definitely slope-intercept form. Armando, number 3, what do you got? Good. This is the one that was probably new to a lot of you last year. This is our point slope form. All right, where we need a point, we need a slope. All right, and then Jada, number 4. Yeah, also point slope form. Okay, so just kind of know by looking at it sort of what form it's in, what our answers should look like when I eventually tell you to write the equation. It should look like one of those 2 versions. Okay. All right, 5 through 6. I give you the slope and I give you the y-intercept. I want you to write the equation of a line in each form. So slope-intercept form is the whole y equals mx plus a b. In order to go right to slope-intercept form, we need to know our slope. Do we know our slope? Yeah. So we're just going to slot the slope of 4 right in here. And we need to know our y-intercept. Do we know our y-intercept? Yeah, I just flat out give it to you. It's an 8. So we just put the 8 right there. That's slope-intercept form. All right. Now, point slope form looks like this. So this is going to be y equals m and then x minus this x minus a 1 plus a y sub 1. And let's kind of talk about what those things mean. The m is still your slope, just like it is in slope-intercept form. So that should be really, really easy. Our slope is still 4. So I'm going to erase the m. I'm going to replace that with the 4. All right. Then this is the x coordinate of the point that we know. This is the y coordinate of the point that we know. Well, when I give you your y-intercept, so let me open up a new one real quick, just so I can draw this nice and big. If I were to draw a line with a y-intercept of 8 up here, And I now ask you to identify what that is as a point, like a coordinate pair. What point is this? So if I ask you what's x, what's y, Armando would be what?
0, 8.
Good. So whenever I cross the y-axis, won't my x-coordinate always be 0? So the point that we know and the one that you are looking at on our paper, that point is 0, 8. So what that now means is, notice this little x sub 1. What I'm going to replace right here is the x-coordinate of the point that we know. And in this case, that's a 0. So I'm going to have x minus a 0. And then you see your y sub 1. That just means the y-coordinate in the point that we know. The y-coordinate in the point we know is that 8. So I'm going to erase that, and I'm going to slot in an 8. That's what that looks like in point-slope form. Okay? You're more familiar with slope-intercept form. Point-slope is actually the best of them in the sense that you can write equations lines very easily. You don't know the y-intercept. All right, so with real quick, do 6 if we understood that. So you're given the slope, given the y-intercept, write the two different versions in number 6. All right, Karina, what do you have for number 6? For the slope-intercept form one. Good. Make sure you put the x there. Negative 3x. And then, yeah, minus a 2. So that's our slope-intercept version. And then this point slope. Do this one here. This is, again, the form. M times x minus x sub 1 plus the y sub 1. The x is the x-coordinate of the point we know. If it's the y-intercept, we know that our x is a 0. And then our y had to be that negative 2. So in this spot right here, oops, you're going to replace that x sub 1 with the x-coordinate of 0. And then the y-coordinate in this point is a negative 2. You can put plus a negative 2. That's not wrong. But if we were to simplify it, it would just be a minus 2 on the back side of it. All right. All right, so now let's say we go to these guys. So now let's go to 7. It says, given a point and a slope, write the equation of the line in each form. So what I want you to do first, go ahead and write this first. So write point slope on the left side where you got some work or room to work, and then write slope intercept on the right-hand side because we need to do both. Because here now is why point slope is really nice. If I give you slope intercept form, the only way we can do that right away is if I know the slope. Do we know the slope of this line? Yeah, I gave it to you. It's a 1/2. Do I give you the y-intercept in this one? So do we know the y-intercept here? No, the only way it would be the y-intercept. So if we look at this point, if this point had an x-coordinate of 0, then yeah, that's the y-intercept, and we could throw a 5 right there, but it's not. So because of that, we don't know what the y-intercept is yet. All right, you weren't given that like we were in those first couple of problems. So jumping right to slope-intercept form is impossible. But point-slope form, we can always do right off the bat. So that's why point-slope form is actually really, really useful as we kind of move along, because it's any point and that slope. So if I now go ahead and substitute in your m. We know that's the 1/2. And then I'm going to do x minus the x-coordinate of the point that I know. In this case, that's a 12. And then I'm going to add the y-coordinate that I know, which is a 5. So this is our answer in point-slope form. Now, the nice thing about point-slope form is we just simplify this. As long as I just simplify this, this should give me my slope-intercept version. So here's what I now mean by that. So over here underneath slope-intercept, because this is our answer, all I'm going to do, notice how I have this 1/2 here. We're going to distribute the 1/2. So take the 1/2, multiply it by x. Then take your 1/2, multiply it by that negative 12. So what's half of 12 is basically all you're asking yourself. And half of 12 is 6. And then we still have that little plus 5 hanging out at the end right here. Notice how you have like terms. You have 1/2 x. Combine these like terms to get a negative 1. Isn't this now in slope-intercept form? Yeah, and we know our y-intercept is actually a negative 1. So that is our slope-intercept form for that equation. Okay? So 99% of the time when we do these, we're probably going to be putting these in the point slope form first, unless we just know the y-intercept. Okay? We follow that? Any questions on that? Okay, then go to number 8. Unless you're given the y-intercept, which we are not, this is not the y-intercept here, you want to put this in the point slope form first. All right, so do that. Let's refamiliarize ourselves with this form. All right, and Ella, what'd you get for the point slope form? What was our M? 2. And then in the parentheses, you would have had what?
X plus 2.
Good. Stop there real quick. So this happens a lot with our slope. It's happened, we've seen it with the quadratic formula. This is initially x minus your x coordinate, and then the x coordinate is a negative 2. So you get that little double negative there. So that's why she ultimately just said x plus 2. So good. And then what we got in the back? Good. And then plus 4. So that's one of your answers. If I ask you to write the equation of a line in point slope form, you're done. All right. That would be all you have to put down. All right. This one, though, obviously I'm telling you to do it in the each form. So now if I want to put this in the slope-intercept form, we can't just jump right to that because you weren't given the y-intercept. But I can now take that answer that I just wrote that Ella gave us and just clean that up a little bit. Just simplify that right-hand side. So that would just mean we're going to distribute the 2. So 2x plus the 4. And then we still have the extra 4 hanging out in the back. Combine the 4s. And then this is our slope-intercept version. All right, y equals 2x plus an 8. Okay, I think 9 is the last one on this page. Yeah, go through number 9. Get both of those. See if we can handle that. Yeah, just be careful of signs in terms of everybody's kind of understanding the process. So the point slope form first is the one that I'm going to use because you're given the slope, you're given a point. It kind of tells you which form you want to start with. All right, so when we do that, Omar, what would yours look like?
Y equals -3. X plus 4 and X plus 7.
Good. We would have had minus a negative 4 here, so make sure this is a plus 4. That's the answer to that one. You're just done. You don't have to do anything else with the point slope version. And then the slope intercept version is us now just taking that and simplifying it. So when we now distribute, the -3 and the x make a -3x, the -3 and the 4 make a -12. Make sure that's a -12, and then we still have the +7 there. So if you got -3x, what'd you ultimately get here, Jada? Would you simplify that to, Jada? Good. And then we should get a -5 for our y-intercept. Okay. That's our slope-intercept form. That's our final answer for that. All right. So now go to the next one. Let's say I don't tell you specifically which one to do. This says write the equation of the line to the right in slope-intercept form. So do that. This is probably what you did endlessly. 8th grade. You did a bunch last year in Math 1. So write the equation of that line in slope-intercept form. Well, the slope is a little sneaky here. All right, let's do our y-intercept first. Can I look at this line and easily determine where that thing crosses the y-axis? Yeah, where does it cross y-axis at, Caden? Good. So we should have a +3 right here. Then your slope, just be careful of. So when I find this slope, just make sure that it's crossing the corner perfectly. So I gave you this grid here. Make sure it's crossing a corner perfectly. So like here, it definitely crosses perfectly at a corner for all of these squares in there. I would not use this right here. Is this, it's nice and big. Is this really crossing exactly at x = 2? No. If we continue on, it looks like maybe it crosses here, but again, it is definitely not crossing perfectly here. The next place where it really crosses nicely is all the way down here at the 5, -4. So the 2 points that we should be using to count off our slope, this is your whole change in y over change in x, rise over run, however you probably heard of all of them when you were doing all of these. Those are the 2 points we want to use to count off. Doesn't matter which point we start with. So I'll call this point 1. I'll call this point 2. All right, Omar, what point would you want to start at? Point 1 or point 2? All right, so if I start at point 1, what do I have to do to get to point 2? Start at point 2. All right, then we're going to do what? Good. We're going to rise 1, 2, 3, 4, 5, 6, 7. So recall our slope is your, again, however your teacher or however you remembered it, because I'm sure they showed you all of them. You can think rise over run. You get the whole little change in y over change in x, however you want to think of it. So Omar used the word rise, so we'll use that. We rose 1, 2, 3, 4, 5, 6, 7. So that's our numerator. And then we did what, Omar? Good. And then he ran to the left. How many? 1. Good. So then left 5 means -5. If you would have started at point 1 to 2, you still get the same slope. All right, should be a -7/5 as our slope. So we come over here, substitute that in. Oops, let's back up. And that should be our slope-intercept form. Okay. All right, now let's make that not so big. All right, a little quick refresher there if you didn't remember how to kind of do the rise over run, change in y, change in x, whatever. So now do 11, same idea. You're given a really nice y-intercept. We can easily just look at it and determine it. And then find your slope and write the equation.
Could I take the test tomorrow during my study hall and lunch? I can't today because I'm making up
Okay,
Spanish.
now's not the time though. Let's talk after. Okay. All right, slope of this line We'll stick with the rise over run idea since we used that for the first one. A lot of points to choose from. Here's a good point. Here's a good point. This one crosses a lot of corners for you to count. And again, it doesn't matter which point you start at. So I've got 6 of them marked right now. It doesn't matter which one you start at. It doesn't matter which one you go to. You should still get the same slope. All right, so for that one, Jake, which one do you want to start at? Point.
1.
All right, so he's going to start at point 1, and let's just go up to point 2. So we're going to do what to do that, Jake? Good. So we're going to rise 2. So up 1, up 2, and then we have to do what? Good. Left 1. Left means we're a negative 1. So 2 divided by a negative 1. Our slope here should have been a negative 2. All right, and then the easy part, let me make this a little smaller now. What is our y-intercept then, Jake? Good. This point right here is where we cross the y-axis. That is a negative 1, so that's our y-intercept. All right. All right, good with those? All right, because 12 is now different. And the reason 12 needs to be different, let me make this big for you to see this good. Does this cross exactly at a nice integer value along the y-axis? No, and you're not going to guess. So we're not going to look at this and say, yeah, it looks like maybe it's like a negative 2.5, because we don't know that. Could be negative 2.6, could be a negative 2.7. Like, we're not going to guess what that is. All right, so that's why point slope is, or slope intercept form is a little bit limited, is because you're completely dependent, if we're going to go right to that, on knowing what that y-intercept is. Numbers, the first 2 we could, this one we cannot. So when that's the case, that's why I would tell you to do this in point slope form. All right, so let's rewrite that general form first. So it's going to look like this. Notice how we still need the slope. So do that. We still need to look at that line and be able to identify our slope. So do that real quick. And then whatever that is, you're going to put in front of the parentheses. And again, you got a ton of points to pick from. All right. So Monica, give me a point to start at here, Monica. What do you want to start at? Say it again. Say that one more time. All right, so she's going to start over here at point 9, and then you're going to go to point 8. So we're going to do what to go from 9 to 8, Monica? Good. Rise 1, so we're going to go up 1. So that's just a positive 1. And then once we're here, we need to do what? Good. Left 2. So that should be a negative 2. So our slope, negative 1/2. So in our line, you're going to put the negative 1/2 there. This. And then now we need a point. On the first page, I just gave you a point. Now we need a point that we know for a fact is on that line. So look at your line and pick any point you want, because there can definitely be some different answers here. In fact, there's 9 different answers because I have 9 different points that I can easily identify. Oh no, do that. All right, and Ben, what's your favorite point there, Ben? Number 1, 2, 3, 4, 5, 6, 7, 8, or 9?
5.
All right, so he picked point 5. If I pick that point right there, we just identify what is this point. So if you pick that point, this point has an x coordinate of -7 and a y coordinate of 1. All right, so if you're going to use Ben's point, let me make this smaller now. He used the point -7, +1. So his would look like x minus a -7 and then plus a 1. So really x plus 7. Now, my guess is most of you didn't use that point. So pick your point, pick any point you wanted, write your line. Okay. Now, this is your final answer, but what I want you to now do, even though I'm not asking you to do that in this problem, just to show that these are all going to be the same, let's put this in the slope-intercept form. So take your line, distribute the negative 1/2. We should all have a negative 1/2 in front of it. So negative 1/2 times the x, everybody should have a negative 1/2 x, no matter what point you picked. Here's where our answer is going to differ a little bit initially. A negative times a positive for me is a negative, and then half of 7 is 3.5. So depending on what your number is, this is going to be a little different. That's okay initially. Just do half of whatever that number is. And then we still have the little +1 hanging out at the end. Now, here's what should happen for everybody. When I now simplify this, we should all get magically the same answer of this, regardless of what point you picked of those 9. Notice our y-intercept. Do we all get the y-intercept of -2/2 with your point? Does that make sense? If we go back to this, doesn't it appear as if it was going about -2.5? And now we know for a fact that it was, right? Okay, last one of these. Do the next problem. So no help, pick your point, find your slope. We can all have different answers here because there's a lot of points. How many points we got? Yeah, there's a number of points you could pick from here. And again, we want to do that because we don't know that y-intercept. We don't want to guess what that y-intercept is. All right, then do me a favor too. Go ahead and put that in slope-intercept form, and then we'll see if you all get the same answer ultimately in slope-intercept form. So if you get point slope form right away, simplify it, and then we'll see if you all get the same answer. You might need a calculator. Yeah, there's some ugly decimals here. That's why it doesn't cross the y-axis nicely. Okay, let's do the point slope version. First, we need our slope. All these, we need a slope. Alec, what did you get for the slope?
1/3.
Good. All right, do we all get 1/3? If we look at this, if I make this nice and big, if I pick this point here, I go up 1, then right 1, 2, 3, up 1, 1, 2, 3, up 1, 1, 2, 3. All right, so that's our slope, 1/3. And then what point did you pick? Just tell me the point.
I got the point where x equals 2 and y equals 3.
Good. So he picked this point right here. All right, the one that I made really big. And at that point, the x coordinate is 2, the y coordinate is 3. Your point might be different. That's okay. But if I'm going to use that point 2, 3, then we're going to do x minus that x coordinate of 2, and then plus your y coordinate of 3. As long as you have an actual point, you plug it into your formula correctly, you should be good. All right, we would all get the same exact thing. All right, so this answer would look a little different. That's okay. Let's now clean up this one that Alec gave us, and then if you had your own, if you tried your own, let's see if we get the same thing. So distribute the 1/3, so 1/3 x. Don't overthink this. 1/3 times 2 is just a negative 2/3, and then plus our 3. Let's even do it as a decimal, since I think that's probably what your calculator is going to give you, and it'll make some sense. If you did a negative 2/3, or whatever your answer is, whatever your problem is, your numbers, and we add that together, that should give you, what is that? 2 1/3, so 7/3, so 2.3 repeating. All right. Let's look at our graph now. is it reasonable that our y-intercept here was 2.3? Yeah, because it was right in between that 2 and the 3. And that's why we don't want to guess, because we don't necessarily know what it's going to be. All right. Okay, good with that. Okay, then real quick, last two problems. It says, using the tables below, write the two different equations for your linear function. Again, the only way we know our slope-intercept form is when the x is a 0. Do I give you the x value of 0? No. But what a lot of people will do, and that's not necessarily wrong, you could work your way backwards. You could follow the little pattern here, and you could probably figure it out. And if you could, jump right to that. Okay? What I would like you to do, though, is let's do the point slope form because we don't know our y-intercept. And we still need that slope. So the way you would have found the slope with that table, it is still your changes in y divided by your changes in x. That's your slope. So what you probably did a lot, we did a lot of these in Math 1. Notice how we increase by 3, we increase by 3, we increase by 3. So my change in y is a positive 3. Then go to the opposite side. Notice what your x's are doing. My x is increased by 1, increased by 1, increased by 1. So we're adding a 1 every time here. So my change in x is a 1. So our slope is 3, just 3 over 1. All right, then Jada, which point do you want to use? The 3, 4, 5, 6, 7 point, which one? All right, so if we're going to use this point right here, we can now write the equation of that line. So take the x value of 3. So we'll do x minus a 3 there. And then the y coordinate there is a 4. So we take a y value of 4, plug that in right there. That kind of looks like a y though. Let me try that again. And then now what we can do to get slope intercept, just simplify this. So now just come over here. Let's distribute that 3. So 3x minus a 9. And then add that 4. Combine those like terms. And then this is our slope intercept form. Okay.